All right, today I want to talk about exponents and why they're important, how to simplify them, what's some vocabulary words that are important, like the base and the exponent. This is a very important topic that you will expand on for later on. But today, as you see on the screen, I want to answer the following questions. How can I simplify expressions by using exponents? What is a base? And what is an exponent? So let's get to our lesson for today. Why simplify? So let's answer that question first of all. You get this question a lot of times asking why simplify or simplify this expression or make this in the simplest form. So in math, you oftentimes are given problems and they're asking you to simplify this. In this case, it may be take all these numbers and write it in a simpler form. So we'll do 4 times 5 is 20, plus 3 more is 23. Obviously, 23 is a lot easier to look at than that. Or you may hear the word simplify for a fraction. You may see 20 over 5. And that's a little bit complicated, but it's easier to say 20 divided by 5 is 4. Or a little bit closer to the subject at hand, you could write, let's say you had $2 every day. 2 plus 2 plus 2 plus 2 plus 2 for a whole week. And you wanted to know, man, if this continues, how much will I have in 30 days? Well, you have two options. You could count up 2's 30 times, or there's a simpler way to do it, isn't there? And I'm hoping you're saying it before I get there. Yeah, you could just say, instead of saying 2 plus 2 plus 2 plus 2 plus 2, someone realized that you can use multiplication and just say 2 times 7. So we simplified this process by doing it that way. Well, what does that have anything to do with exponents? Well, just like we simplified that by saying 2 plus 2 plus 2, let me see if I can get a more dynamic color. What if you had 2 times 2? As a matter of fact, what if you had 2 times 2 times 2 and times 2 and times 2? How would you simplify that? Well, that's the same thing as 2 times 2 times 2, and I can add it all up, but is there a simpler way to write it? That's what we're going to discuss today, because there is. And we can rewrite this as 2 to the 5th power. Some students may confuse 2 to the 5th with the same thing as up here, 2 plus 2 plus 2. But in actuality, we're dealing with a different operation, aren't we? We're dealing with multiplication. So we want to say 2 times 2 times 2 times 2. And of course, if I had 7 2's all multiplied together, I'm going to do 2 to the 7th. And so let's get into that and looking at some examples that bring this point home. So what is a base? What do I mean by base? Let me go back. So by base, let's take the problem we just did a second ago, where we had 2 times 2 times 2 times 2 times 2 is equal to 2 to the 5th power. Well, this 2 right here is called our base. And you can guess what the 5 is going to be considered. Yep, our exponent. So that's the vocabulary you need to remember. And it's kind of easy, right? Because a base is usually on the bottom for most other things too. So this base is where the exponent is connected. Now notice that the 5 is a little bit above the ground, if you will. This is called a superscript when you're writing a little bit above. If you're writing a number a little bit below, like a 2 down here or something, that would be called a subscript. So in case that word comes up, it won't confuse you. So we have an exponent and a base. So that's how you recognize the two. Quick quiz. Looking at this number, which is my base and which is my exponent? What is the base? Good. It should be 3. And my exponent is 4. Pretty straightforward. But you don't realize how important it is to get these vocabularies, words down in order to answer the future questions, because it makes it so much easier when you can understand actually what they're asking for. All right, what is exponential notation? Well, it's easier for me just to show you a little table. So here is exponential notation. Exponential notation is what we just was looking at a second ago. When you put the base and exponent together, we're going to call that exponential notation. Now, how would you read something like this? You can call this 7 to the second power. But we have a special way of calling it if it's a 2 up here. We can also say that's squared. So, given another example, we could call how would you read this? You can simply read that one 8 to the second power, or 8 squared. All right, so maybe it's easier to read these others now. What about this one here? How would you read that one? Well, that's 5 to the third power, or 5 cubed. Again, the exponent of 2 and 3 have special names that you can also use. You can say 5 to the third power, or 5 cubed. And the reason why we can call this a square, because later on we'll learn that 8 squared is really talking about a square with a side of 8. Because 8 times 8 will tell us the area of that square. So when you measure something that's two-dimensional, length times width, we're going to count how many squares are consistent in this. So in this case, we're going to say this is 64. Let's say it was inches we were measuring. Let's say this was inches. So that'd be 64 inches squared, or 64 square inches. You're going to sound pretty intelligent now. What they're basically saying is if you were to cut this thing up into 8 columns, I don't know if that's 8, but you get the idea, and 8 rows, guess how many squares you're going to end up with? Yep. You guess it's 64 squares that are 1 by 1. You're going to 64 1 by 1 squares all in here. That makes up 64 square inches. Now, why do we call it cube? Well, you know what a cube looks like, right? So a cube doesn't have 2 dimensions, it has 3 dimensions. And we measure cubes, or volume with cubes, with a formula of length times the width times the height, because it has 3 different dimensions: the length, the width, and the height. And it doesn't matter which one is which, because they're all going to get multiplied and come out to the same answer. So in this instance, we're wondering how many little cubes will fit inside this box, or this big cube. So in this case, it'd be a perfect 5 by 5 by 5. So every side, every edge will be 5. So that's where the names come from. And those are the most popular that we'll use, squared and cubes, in real life. 9 to the 4th power is how you read this one, and 12 to the 5th power, this last one. How about we do a little practice? Well, I would encourage you to pause it here to see if you can answer these 4. Write each expression in exponential form. We just covered that. All right. You should have worked it by now. A should be 16. How many 16s are being multiplied? 1, 2, 3, 4, 5, 6, 7. 16 to the 7th power. And what about B? Well, there is a base of 9 being multiplied each time, 5 different times. So the exponent of 5, 9 to the 5th. And for C, we have a base of x. So this one's interesting because we say, oh no, where the numbers go? It's still going to be the same basic concept. But this is now going to be x to the 4th power. And now we have A to the 1, 2, 3, 4, 5, 6, 7, 8. 8th power. So, and notice how we read those. X to the 4th power, A to the 8th power, 9 to the 5th, and 16 to the 7th. All right, so let's continue our practice by going backwards now. How would you write this in expanded form? if you wanted to expand it all the way out. See if you can pause it here or just at least mentally visualize what this is going to look like. And how do you say this anyway? Good. I hope you said a to the 6th. And what about this one? X to the 5th power. So now let's write it in exponential form. So let's do a first. This is going to be a base of a 6 times. Simple enough. 6 times. And what would b look like? Let's get a different color. So b would be x. And that one can be a little trickier, right? Because we got an unknown, but it's still the same concept. X times x times x times x times x. So that's how that one would look. So pretty straightforward. Let's see. How would you simplify this one? 3 to the 4th. How would you simplify? I mean, you may be thinking, it's already simplified, isn't it? Instead of 3 times 3 times 3. 3 times 3 times 3 times 3 is what I meant. It's already simplified, but you can simplify it even more. Instead of 2 numbers there, 3 and 4, there could be 1 number. Well, to simplify this the best way, we can just solve it. Well, what is 3 times 3 times 3 times 3? Well, 3 times 3 is going to be 9, so that takes care of that. And now I got 9 times 3. Well, 9 times 3 is 27. So there is that. And I got one more 3 to multiply 9 times. 27 times 3 is going to give me 81. So when this gets simplified, it goes down to 81. Can you see how that's a simpler answer than 3 to the 4th? Much easier on the eyes too. So just 3 to the 4th. And that is everything on the exponents for an introduction. Did we accomplish our goal? Let's look. We asked, how can I simplify an exponent expression by using exponents? Yes, we did that. We simplified expressions using the exponent. And did we learn what a base is and the difference between a base and an exponent? Absolutely. Great job. Thanks for tuning in, and I hope to see you next time.